In class, we talked about the average rate of change. Average rate of change is just another word for slope. But in college algebra, we're getting ready for calculus. And in calculus, you're going to be computing the slopes of lots of different functions, not just lines. So I want to look at a couple of examples. If we're given a function and we're given some starting point and ending point, how can we find the average rate of change? So we're going to start out with a simpler example. Here we're asked to find the average rate of change, or the slope, for the function y equals 2x plus 1 from x1 equals 0 to x2 equals 3. Well, this happens to be a line, and what's unique about lines is that they have the same average rate of change, or the same slope everywhere. I've graphed it here, y-intercept of 1, count 2 over 1, up 2 over 1. The slope is 2 no matter where you go. So for this particular example, we don't need this formula, but I'll show you how to use it anyways, because we had a line, it was in mx plus b form, and so from that form, I know the slope is 2. I know average rate of change means the same thing as slope, so I already have the answer. But I'm going to show you how to use the formula because we're not going to really be doing this with lines, we're going to be doing it with things that are nonlinear. So let me show you, it's a longer way, but it is the way you're going to have to do it when you don't have a line. So let's say you don't have a line. So the first thing you're going to do is find y1 and y2. Most of the problems are going to give you x1 and x2. So if they give you x1 and x2, you're just going to plug them in the formula for x. So they said that this was going to be 2x plus 1. So when x is 0, that's 2 times 0 plus 1, or 1. Which means the actual coordinate we're interested in is the coordinate 0, 1. There it is right there, 0, 1. When x2 is 3, we're plugging in 3 to the formula. 2 times 3 plus 1 is 6 plus 1 is 7. That's a little off my graph, or actually I think it's this one right here, right? 3, 7. So we're looking for the average rate of change between those 2 points. We already know it's 2, but we're still going to try the formula to find it out. So here's the average rate of change formula. It is the slope formula because average rate of change is the slope. And you're going to plug in the y's. So 7 minus 1 in the numerator, and then plug in the x's. 3 minus 0 is in the denominator. So 6 over 3 is 2, but we already knew that. Now, they're not always going to be lines. That's the whole point. Calculus exists so that you can find how something is changing when it's not linear. So we're going to look at an example down here where it's not linear. This is a cubic function, x cubed minus 1.5x. If you have a graphing calculator, you can go ahead and look at it in the graphing calculator. If you don't, you can go ahead and go to www.desmos.com and look at it there. Now, I can't show you Desmos while I'm on my phone because Desmos is on my phone. So I did go ahead and put it into the graphing calculator. I'll show you what it looks like, kind of. And this is kind of what it looks like. I transferred that over here a little bit. It does a little change here, but notice the scale. It gets really big. It goes all the way up to 60 on the y. But what are we looking for? We're pretending that it's a line. We're pretending that the best we can do right now is estimate the average rate of change by computing the slope. So just by looking at this, what I can predict is that I'm going to have a positive average rate of change because from -1 to 4, this graph is getting larger. Even though it gets a little smaller and goes back down again, on average it's getting really big. There's a lot of gap here. It's not a great estimate, but it's the best we can do in college algebra. So now that we kind of understand what we're looking at, it's the same steps as before. First, we're going to find y1 and y2. So once again, they gave us x1 and x2. They also gave us the function. So I'm going to plug in -1 here, and that's going to give me -1 cubed minus 1.5 times -1. I did that on my calculator. So on either calculator, you're just going to plug in exactly what you see, -1 cubed minus 1.5 times -1, and I got 0.5. Now here a decimal is okay. Why is a decimal okay? They gave you a decimal in the original problem. That's a pretty good rule of thumb. If there's a decimal in the original problem, decimals are okay. If there's a fraction in the original problem, there should be fractions in your final answer. So that's how I got 0.5. Then I can do the same thing for 4. Plugging in 4 for all the x's. That's how I knew it was going to get really tall. It's got a y value there of 58. So these are now my 2 coordinates, and I'm trying to find the slope. I mean, if you can repeat it to yourself over and over and over again, average rate of change is just slope. You'll be doing yourself a favor. Maybe every time you do a problem, repeat it in your head, or even repeat it out loud. So here's average rate of change. It's just slope. 58 minus 0.5. Be careful down here. There is a negative in the formula, so 4 minus negative 1 gives me 57.5. 4 plus 1 is 5. I put this in my calculator, and I am leaving my answer as a decimal because there were decimals in the original problem. So this is a growth. This is 11.5, a kind of steep slope, and that makes sense looking at my picture the way I have it there.